Okay, so they've told us the exact value for sine, and all they told us about cosine is that it is positive. So again, we'll center ourselves on the origin. On this one, we're not necessarily on the unit circle. We may be, we may not be, we don't know that for sure yet. So we know that the sign is negative. What that tells us is that we're in either Q3 or Q4. The fact that cosine is positive tells us we are in Q4. So just the sign work tells us we are in quadrant 4. So our y value basically is the -2. That means the hypotenuse has a length of 7. So this is not a unit circle. This is a circle with a radius of 7. So -2 squared plus x squared equals 7 squared. So x squared is 49 minus 4. So x squared is 45. So x is root 9 root 5. So x is 3 root 5. And there's our theta. So now we have everything we need to get the remaining angles. So cosine theta. Okay, so our cosine is our adjacent x value over the hypotenuse, so that would be 3 root 5 over 7. Our tangent is either sine over cosine or y over x, so -2 over 3 root 5. And then we just rationalize, multiply top and bottom by root 5. So we have -2 root 5 over 3 by 5, 15. So the other three trig functions are just reciprocals. So reciprocal of sine is cosecant. So that would be -7/2. Reciprocal of cosine is secant. 7 over 3 root 5, and just rationalize. Multiply by 1 is root 5 over root 5, so we have 7 root 5 over 15. And cotangent, of course, is the reciprocal of the tangent, so that would be -3 root 5 over 2. So just flipping the tangent, and I took the liberty of flipping the original version of the tangent rather than flipping this one, rationalizing and reducing. All right, so one last property in this section, and that is parity. Even versus odd. So I'm just going to think of an arbitrary angle theta here. The cosine of theta, notice, would be the same as the cosine of the opposite of theta. So whether I turn up this many degrees or down this many degrees, as long as it's the same number of degrees, the x value is going to be in the same spot, making this an even function. Now, since the secant is based on the cosine, as sort of a freebie with that, the secant of theta and the secant of the opposite of theta are the same. But as far as sine goes, we had a positive output here. We had same distance from the axis, but opposite side, so the sign flips. So the sine of opposite of theta is the opposite of the sine of theta. In other words, sine is an odd function, so its partner as a freebie, cosecant, also shares this property. And with those, without even having a drawing, just using sines and cosines, tangent of the opposite of theta would be the sine of the opposite of theta over cosine of the opposite of theta. Sine of the opposite of theta is the same as the opposite of sine theta. However, cosine opposite of theta is the same as cosine theta. So notice this is negative tangent theta, or opposite of tangent theta. So tangent is also an odd function. And unsurprisingly, then its partner, the cotangent, would have the same property for much the same reason. So for example, if they ask for the cosine of pi over opposite of pi over 4, that's the same as the cosine of pi over 4. That's a 45 degree, so that is root 2 over 2. If they want the sine of negative pi over 3, though, that's the opposite of the sine of pi over 3. Pi over 3, 180 over 3 is 60, so 6 degrees, so that's root 3 over 2, so this is negative root 3 over 2. Tangent of, we'll do a more challenging one, negative 31 pi over 6. It's the opposite of the tangent of 31 pi over 6, which is the opposite of the tangent of, well, 30 pi over 6 is 5 pi, so we'll turn it into 1 pi over 6 plus 30 pi over 6. So that's the opposite of the tangent of pi over 6 plus 5 pi. So even though this is an odd, not an even, remember a tangent had a period of just pi, so any integer multiple of pi is the same as the original. So then this is the opposite of the tangent of pi over 6. So at pi over 6, 180 over 6 is 30, so 30 degrees. Our sine is at 1/2, our cosine is at root 3 over 2, and I'm just carrying this negative sign along. So 1/2 times 2 over root 3, so that is 1 over root 3, and then just rationalize it. So root 3 over 3, and we bring our negative sign along. All right, so if you're doing the textbook problems, this was 6-3. Try out 5 to 10 all, 11 to 87 every other odd, 93, 94, and 113. Otherwise, you can just try the My Math Lab problems, whichever one. The choice is yours. All right, any questions, get in touch with me, and make sure you stay safe out there. Thanks very much.